Good afternoon. Welcome to the VoIP Wars, the Phreakers Awaken. You're in Mandalay Bay, GH, and your speaker today is Fatih Ozavci. Before we begin, a few brief notes of housekeeping. Please stop by the business hall located in Bayside AB if you haven't done that already. The Black Hat Arsenal is on the Palm Foyer on level 3, and of course the Arsenal reception is at 1700. If you haven't picked up your merchandise today, is your last chance to visit the Black Hat Swag and Bookstore, so make sure you take a look at that. Visit the Kali Linux Lab in Mandalay Bay A. And thank you also for putting your phone on vibrate during the presentation. And if you look around, there are 5 microphones, so there will be a Q&A at the end of the talk. So please try to step up to a microphone so that we can all hear your question. And without further ado, I present Fatih.
Thank you. Thanks. My voice is clear for the back rows. Everybody hears me? Nice. I'm here to talk about voice over IP, but voice over IP is the blind spot of the current IT security world. So I have provided vPro and voice over IP Wars research series in major security conferences to change this with some practical attacks. So maybe I can get more attention for voice over IP. So voice over IP Wars had 4 different presentations. Yes, it is a series, just like the original one. But the challenge is every presentation is presented for something else. Actually, sometimes it is for protocols, sometimes it is for a specific product line or cloud services, but sometimes it is much more general. In this context, I will talk about voice over IP Force, the Phreakers Awaken today. My name is Fatih Ozavci. Actually, I love VoIP and phreaking, but I also work on mobile applications, mobile devices, network infrastructure, especially service provider networks, consumer devices, and etc. So I try to combine almost all these techniques to find new vulnerabilities and new research areas for myself and for my customers, of course. And I'm also author of vPro and Voice over IP Wars. vPro is a tool, and we will discuss this in our further slides. I also had public speaking and training sessions in major security conferences, including Black Hat, DEF CON, and Troopers. So you may see the other videos to maybe learn more about some specific attacks. Today I will talk about the UC and IMS fundamentals first. So everybody will be on the same page before the presentation, because we need to understand what is unified communications, what is IMS, and what is voice over IP, and how can we attack using voice over IP or unified communications or targeting the services themselves. So we have a few different points of attacks. So I will target the clients, I will target the servers, sometimes architecture, and I had some shiny demos in my previous talks as well. So sometimes I will refer them. Also, I will talk about some different designs, various implementations of voice over IP and unified communications. This includes cloud security or call center security, IMS and service provider networks, and I will talk about their security and some design issues or vulnerabilities. And after that, we will talk about practical attacks, and I will demonstrate a few practical attacks. So you will see how they work or not. And of course, I will have some suggestions to make it secure. In the first communication day, we had Alice and Bob, and Alice can call Bob, who is a call center agent, to discuss things. Let's say taking a support from Bob. But Alice could talk only through a traditional system. So we had only voice. Though this changed because we had another architecture, and Alice needed to use voice over IP. And voice over IP had 2 channels, signaling and media. Signaling is responsible to handshake with Bob and the service providers. And media transport is required to transfer audio and video. But this had no significant change on Alice's world because Alice had same audio again, and maybe she can send SMS messages and etc. But unified communications evolved in years. So Alice had more options these days, and she can send her bill through the same session to Bob to discuss about it. Bob may open a marketing presentation to Alice to get a kind of discount or something like that. Or Alice can ask Bob's support for a remote desktop sharing through the RTP session. They are all possible in this unified world, and we call it unified collaboration. Of course, every one of them comes with a new attack surface. And we have too many different attacks here. So we can combine old techniques and new techniques to build successful attacks. Sometimes it is just like blue boxes or bypassing lines. Sometimes adding some call spoofing and adding some additional things and combining them. For example, cross-site scripting is possible through the SIP calls. So just imagine, you can send a SIP call to someone else, including a cross-site scripting content, and waiting for a sort of shell from a phone. This doesn't sound right, but it is possible in a kind of major product. And it was your day when I was presenting this in Europe, Black Hat Europe. So there are different attack surfaces in this context, including some RDP attacks through RTP tunnels as well. Let's focus on the basics, how SIP works and RTP works. If phone A wants to call phone B, it needs to register to a SIP server with credentials or not. After the registration, it needs to send an invite request to the server, and server will forward this request to the callee, in this case, phone B. That request must be forwarded because it will have STP and XML content, because phone A and phone B must handshake about the audio or video codecs or RTP options and maybe encryption. So all these options must be forwarded to phone B with some filtering. We will discuss this in future slides. But phone B can say, I'm busy, or I accept, or I refuse, and etc. In this context, it accepts the call using 200 OK. This says that all options are good, but I prefer these options. So phone A offered something, maybe a list of options, and phone B only picked one of them. And it sends its own response. Yes, it is OK. And then phone A and B may have a call. Call may include audio or video and other stuff. And this will be transferred through RTP proxies because phone A may not be able to connect phone B. Sometimes they may be in different locations or different network segregation. That's why we use RTP proxy. All of them comes with additional attack surfaces. For example, caller billing is transferred through SIP headers. I think this microphone doesn't work. This one only works. Just double checking. Of course, STP content is another attack surface in this case because STP content has the call options, audio codecs, sometimes file transfer options, port options, encryption options, and etc. So we can play with them to convince the remote client. Moreover, RTP content. It may have audio or video codecs or some malicious files or some RDP content. So we use SIP and RDP both to attack. I will focus on the signaling ones and some unified communications components, not RTP in this talk. We see these attacks in real life, and sometimes we talk about robocalls, getting some spam. We call it vishing in the VoIP world. There's a kind of terminology. For example, smishing is sending malicious SMS messages, or robocalls, just a robot calling you. But they are actual attacks. Sometimes they are used in bomb threats. Sometimes they are just used for toll frauds to get some cash. The other challenge is also mobile devices under attack because they use LTE. LTE is a next generation network with voice over LTE, VoLTE. So it includes IMS environment, but all those mobile devices basically use SIP. So things may change because everything is based on SIP in these days. You are carrying a phone, and by default, it uses SIP. This may change all the game. That's why I had presentations in Black Hat and other security conferences. Sometimes I focused on the hardware, putting an implant inside the Cisco IP phone and sending it out for a red teaming exercise, or focusing on Cisco UCDM, finding a kind of swap injection, or focusing on clients to find a kind of memory corruption. Or I provided a tool set to manipulate all the tenant phones in a kind of cloud environment, so jailbreaking the environment. So all of them demonstrated live here. And I had some additional attack surfaces as well, and I had additional practical demos. So if you are so keen to learn more about all those attacks, they will be my previous talks. But today I will talk about new attacks. First of all, the larger organizations should have their own communication system. Sometimes they use internal communication. This is a kind of corporate communication network. But it is not suitable for large organizations because there will be some servers and a VoIP server as well, and they will be in a kind of local area network. And the clients, sometimes IP phones, they will use it. The challenge here is VLAN hopping or data network and voice network segregation. They have some design issues. Most of the time, PC ports available on the phones, and this may allow us to VLAN hopping. Or sometimes they allow voice LAN on PC networks as well. Or maybe voice LAN and data LAN are not segregated well. Those are issues, but they have also roaming employees. They may need to use those services, the infrastructure. So there is open services or VPN connections and some filtering. On the other hand, most of the corporations experience toll fraud because they have opened their voice over IP server in the wild. And many people experience this. That's why they migrated this to a cloud solution. So nobody cares the cloud itself. They just focus on the service itself. Phones are connected to the cloud. The integrated servers, such as Exchange, is also connected to the cloud. It is also integrated to the phones and getting voicemails as an email and etc. Moreover, they may have some different locations, and it is also connected to the cloud. But the cloud has its own components. First of all, some services must be dedicated to the customer, the organization. We call it tenant, because this environment is multi-tenant environment. Sometimes vendors use full isolation with some dedicated products, but sometimes they share the product or maybe a product line with some dedicated and shared services. In this case, tenant environment is a sandbox for these purposes. So SIP and media servers, call recordings, CDRs, or all voice over IP related or unified communications related data are stored in the tenant services, the sandbox itself. But most of the time, they have also shared services, which are the cloud services, client applications, management applications, and etc. They are shared services. So if you want to attack those shared services, you may have an opportunity to jailbreak this cloud environment to hijack all phones of all tenants. I have demonstrated this in Black Hat 2014 for Cisco hosted collaboration suite and full VOS environment with some additional 0 days, those days. So cloud has its own problems. But these days, we are talking about also federations, because cloud is not only solution. We need to share this environment with our partners, or maybe just our customers or suppliers. It is just like an email environment. Our exchange can accept emails from everywhere, and it may decide how it can deliver this to the end users or employees. It is same for the federation environment. There will be a network like this in this Skywalker core. The local servers and some local components, they are connected here. And there's a kind of small corporation network, but it is not, a bit bigger. And there's a partner here. It is a Japanese company, Kenobi Corp. So we have two different companies here, and they have only a partnership. They cannot enforce anything to each other. That's why they need to communicate through internet connections. If they call themselves each other using traditional lines, it will be much more expensive. That's why they prefer to use this technique. Federated connections works like connections work like just like that. Phone X tries to reach phone A, and it sends this call request to its own SIP server, and SIP server forwards this request to the edge server. Edge server is the last server of Canopy Corp, but it needs to find which server is responsible to take the call, just like email servers. In the email context, it looks for an MX record in the DNS. It is same for the federated security. And DNS server will have DNS SRV record for the related domain, in this case, Skycom. And it will expose the edge server of Skywalker Corp responsible to take the calls. And this edge server will decide this call is legit or not. Should I accept it or not? So edge servers have really important responsibilities. Isolating the core network from the world and deciding which one is acceptable, which call is acceptable. If it is acceptable and phone A also accepts the call, they will have SIP and RTP connection, including some additional video conference solutions or something like that. So basically, phone A can call phone X or vice versa. There's a kind of issue here. Phone A also can invite phone B without any credentials, just using an email. Or this connection can be shared, or federation security can be established permanently. But they are all different scenarios, and they depend on the vendor. And it changes vendor by vendor. The challenge here is edge servers should work just like email servers. But in our implementations, such as Skype for Business or Cisco or other vendors, they have some limitations. For example, you need to define which edge servers are federated and etc. So the security level is slightly different. They don't work just like emails, but yeah, they try to work like that. This has some issues with restrictions, of course. If we talk about IMS, the scenario is completely different. We are talking about the service provider network this time. And the service provider network may have this core IMS network. IMS is IP multimedia subsystem, and it is a replacement of the next generation of wireless mobile networks. So many service providers use IMS in their core LTE or voice over LTE environment and try to adjust their cost and management and etc. The challenge here is the environment is a kind of enormous beast. There are too many servers responsible to manage all these calls because it's a service provider environment. Call session control function is important to manage all the calls, just like juggling the calls. There are some CSCF servers for this purpose. PCSCF is a proxy server, getting this request from the outside and delivering to the responsible party. ICSCF is responsible for, actually it is interrogating CSCF, so it is open for queries. For example, which subscriber is connected to which SIP server? Because the location distribution or network may be much more segregated or placed to different locations or countries. That's why they use also SCSCF. It is local SIP servers, just like in our networks. So every SIP network is segregated somehow. For example, different cities. Each city has SCSCF, which is a SIP server in this case. And that SCSCF also updates this subscriber information to the home subscriber server, HSS. It stores all the user environment in one single pool. So if some, for example, the user A wants to call user B, it sends this request to PCSCF. PCSCF asks this to ICSCF. Where should I forward this? And ICSCF asks this to HSS. Guy, you have the pool. Please tell me where it is. And when it gets the information, it exposes or reveals SCSCF address. For example, Detroit server. And PCSCF works with that one. This is a kind of juggling the calls. The other problem here is application server, because the application server is responsible to take calls from outside and land them in this core network. But it is also a part of this call network, and it is also a core network. Media resource function is another one. It is responsible to give dial tones or recorded messages and etc. But the most important feature here is it needs to also keep the rooms for the conference and meetings. So it has its own features, and most of them based on RTP. When voice over LTE or LTE subscribers try to connect, it will have PCSCF functions. But this must be a bit application server, but we'll discuss this now. But this network may have also traditional subscribers using DSL cable networks or NBN or fiber networks. So we are talking about two different types of customers here, actually maybe many of them. And application servers should be the handlers for these ones. That's why, first of all, we need to isolate these networks. That's why we use session border controllers. They are basically smart firewall working on a kind of SIP proxy, filtering the SIP calls. Sometimes PCSCF has this function. Sometimes they are independent vendors. And core network. This core network should be isolated like that. And it will transfer the calls. An application server needs host home subscriber services, HSS, to find the users and update their features on HSS. Because the subscribers, the mobile subscribers, also belong to the same service provider, so they need to be in the same HSS. But this also says that there's a design mistake. If you are experienced with this IMS, there are a few design mistakes here. Actually, they are still dangerous. For example, application server should be isolated, and each different networks should have their own HSS as well, if they are isolating the things. So I didn't talk about the clients, but clients under attack because inter-vendor security issues are really dangerous here. Sometimes service providers use third-party software, sometimes they use vendor software. Some devices are compliant but independent, so they cannot enforce security levels. That's why insufficient client management comes with additional problems. Missing security updates, vulnerable systems, missing security features, for example, TLS is not supported. This is an issue. Or just using no filtering for the SIP and STP calls. So we can use all of them to deploy our attack using the centralized environment. We can call all clients using one single call type. For example, using a conference call for all numbers start with 100 to, let's say, 5 million. And it will try one by one all clients and try to call them for the meeting. This is also possible. So if our attack is successful, all these clients will get a kind of successful attack and we will get a sort of shell. I will demonstrate this, by the way. Attack surfaces to clients. There are a few attack surfaces here. We already discussed some of them, but SIP STP content is the most important one, and rich messaging is another one. Because rich messaging may also include some additional formats and different MIME types, including RTF, HTML, or JavaScript, or much more modified files, or corrupted files. SIP STP content is another one because we can play with the components. For example, if we know that a simple audio codec library is vulnerable, we can only offer that library and that codec version. If the client accepts, client needs to use that library, and basically our attack will be successful. Unified messaging may come with additional features for us. For example, file transfers or sharing a presentation. So we may have some additional attack surfaces here. Communication subsystem may have additional ones as well. For example, call and SIP headers and sometimes rarely used protocols. Test approach. How can we use this? How can we test this? This is not complicated, actually. First of all, you need to find the first contact point. Sometimes it is a kind of letter, invitation letter for a meeting, or sometimes just open PBX server, and etc. If you find this, combine all the new techniques for that, and use unified communication techniques for your malicious activities again. For example, MS, RTA, SPF, basically definitions of RTP for Microsoft. So you can use even RDP, remote desktop protocol, through RTP sessions. So why not? Why you don't use it? Please try. You need to plan this attack, find the first contact point, and work on your attack surfaces. If you can find unified communications attacks, maybe you can distribute your malware easily, and then hide your activities and go back to first step. Okay, we need to improve our security testing services, but I have skipped some slides from here because my topic is slightly wide, but I have limited time. That's why those slides available in the final version to be uploaded on the Black Hat web page, but I will summarize them here. Red teaming exercises, it will have IP phones. It will have some additional conference room and media gateways. If so, why we do not modify them? Why we do not intercept the network, and why we do not get persistent access? It is same for human factor pen testing. Sending email may need to bypass almost all security measures such as spam filters and etc. For a call, it's not like that. Only security measures for VoIP systems available on the government organizations. If you want to call the emergency number, you may have a lot of security measures, but for a company, for a larger organization, they have almost none. Infrastructure analysis is another one because service provider networks may need additional attention for this VoIP network because the segregation may allow us to create persistent toll frauds for us. Of course, application security assessment is required for almost all client applications and server applications. But I need to highlight two of them, all these services. The first one is call center. Call centers, almost all of them ignore the encryption used in the VoIP session. So RTP needs a strong encryption, but they may use, let's say, SDES, and sharing the symmetrical key through unencrypted SIP session. So this will expose the RTP session, maybe credit card information in the RTP event. So it may be really visible. We don't need any decoder for the audio. It will be visible there. Or IVR connections, they may expose some additional stuff, or they may be vulnerable for TLS attacks. Most of them important for the PCI DSS regulations. But again, they are just blind spot. It is same for almost all Privacy Act and other obligations as well. And that's why we have some issues. But in IMS environment, we have additional issues. IMS environment may have multi-vendors, some of them for security measures, for example, SPCs. Some of them may be the other ones. For example, just deploying application servers. Network and service segregation is important. They are not just like working in a kind of bucket or a kind of trusted network. We should think about the core network structure now, because it will change. Core network, yes, it will have different servers, but they are not trusted. They are coming from different servers, different vendors, so they may not be compliant. You cannot enforce all the security, and your security must be, let's say, sacrificed. Sometimes you cannot use TLS between the parties, and your network will be unencrypted, but also open for some additional clients. Also, SIP headers, they are also important because they also carry the caller ID, sometimes billing, sometimes they just add routing features. For example, you can pretend that I am a PCSCF, a proxy in this CSCF environment. Would you please give me where I can initiate a free call? And ICSCF will redirect you some trusted SCSCF, and you can initiate your call just because of a header. So you need to add this header and encryption design. As I said, it is broken, but it is also broken for some rarely used protocols. For example, MSRP requires encryption. MSRP is a protocol used for SMS in this service provider environment, and by default, unencrypted. It needs to be forced for the infrastructure. So I talked a lot. I talked about almost everything. So the question is, how can you test it? How can you provide a kind of practical attack surface here? VPROI is an answer because I'm developing VPROI since 2011, and active development ended with DEF CON and Black Hat conference and etc. So it is in the version 4 now. It is available in the web page, vproi.com. It has modules working on Metasploit framework. It is not a kind of independent tool. So you can use it comfortably, just like a Metasploit module. It has more than 20 modules dedicated for cloud service exploitation, phone redirections, pretending just like a skinny client or a skinny phone, impersonating all the calls, adding some custom headers to your calls, and testing everything. I'm not talking about a kind of traditional SIP testers with some limited options. It is very flexible and it does everything almost. Also, I demonstrated almost everything using these proof of concept modules. By the way, they are proof of concept modules. Do not expect a kind of product quality. It has still some features, and the source code is very dodgy. You may get blind if you look at the source code. Don't look at it, just use it. Trust me. And the other one is vProxy. It is required for the MITM analysis, because MITM is also required. We cannot support all features of the clients. File transfer features, sharing screens, and etc. They're not possible. I cannot implement all of them for my tests. That's why I'm using a MITM proxy, which is highly customized for these VoIP clients. So how can we use these tools? I have used this for cloud communications. I had manipulated the skinny calls or IP phones in the cloud environment using XML services of Cisco HCS. Or I have used this for some voicemail attacks, injecting some SIP headers and etc. So it is highly powerful. It is first, it is focused on signaling services in the first place, but it is also expanded now. First of all, signaling services do not cover only SIP. It also covers skinny as well. So it has modules for almost all of them. And the libraries are very flexible, so you can use your customized script. For example, a register is a function. Register to the server and initiate invite calls starting from 100 to, let's say, 5 million. And it will send the invite request regardless of the server response or not, as a kind of DOS attack or a kind of spamming. It is same for messaging as well. You can deploy your messages just like that. Also, vProxy can be used to pretend just like a malicious client, and I will use it as well. How can we use these tools? Most of large organizations use cloud services and some of public services available in the wild, just like Cisco WebEx, Skype for Business, Office 365, or GoToMeeting. So what I did in the first place is, how can I test all of them? First of all, it is not possible. You cannot develop a client for all of them. I can only support some generic SIP extensions. But Skype for Business requires some additional stuff, and we will get there. But first of all, vPro itself can be used as a client. So I can send my request to the other parties, such as callees and destinations. So this request is a signaling request, looking for a call, looking for a message. This request may have customized STP description, customized SIP headers, or customized protocols such as XMPP is a kind of protocol used for signaling as well, or sometimes messaging. So it is also good for us. XMPP is pretty good, but I have no XMPP support. Rather than this, I have a better one, MITM proxy, which is also powerful for search and replace and etc. So you can drive also the XMPP clients such as Cisco Jabber. Anyway, I can send these requests using vPro, and I can manipulate the content. I don't need to send a text message. I can send customized MIME types. For example, sending an image, sending an HTML file with some malicious script, JavaScript, for example. When it is forwarded to the clients, clients need to process this data and forward the request. The important thing is the phone will be ringing, right? Why and when? The decision is based on this STP content. That's why the content must be parsed by clients before ringing. So I target that ring sequence before ringing, before parsing. I try to smash the client. So without any user interaction, I may get shell or a kind of cross-site scripting or script execution, whatever. So no user interaction is required here. So I have a kind of simple exploit here for the MSRP, for the IMS environment. The target is an open source software available in the wild. It is an old legacy software, but fairly used in the IMS testing environments. I saw it in 3 different vendors and 2 service providers. Actually, I was surprised because it's a kind of Not good tool, basically. But the challenge is there is no other tools supporting MSRP and etc. So what I did is sending a customized SIP request with an SDP content indicates that I want to use MSRP, and I will try to transfer a file to you. A file has a longer name, and it is not possible to create that file. In our demo, I'm using vPro, and in the Metasploit, of course, and from is my from field, which is the caller identity. In this case, I am also setting to, which is the callee, right side, the victim, and the server IP address is the remote host. So I have no information of the client except the 700. Oh. So when I send this request, client crashes. And when we look at that request, we'll see the request has a bogus file name in the MSRP file transfer request. And the server cannot identify MSRP is supported by the other party or not, or file name is long or not, or it is a proper SDP request or not. So it is also possible through almost every way. And MSRP is fairly used in SMS messaging, and Android and iOS platforms also have these features for LTE and voice over LTE environments. So SMS sending may be a problem like that as well. But I'm still digging for it. There is no vulnerability like that. But if we want to use unified messaging, the attacks change, because unified messaging may have different file formats. For example, we can change the message type and message content. We can add some additional stuff, for example, pictures or links and HTML content. So it is possible. This may allow us to execute some unauthorized code or script or something like that. Or we can use some additional protocols such as MSRP or XMPP or SIP message. They're also used for messaging. So we can combine all these attacks to make it a practical attack. If we want to use the original client to attack the target server or the clients, we need to configure our client. In this case, I have a attacker client, which is official traditional Skype for business, and I placed my vProxy as an MITM proxy there, but I need to adjust my client. Creating a TLS certificate cloned from the remote server to pretend like that I am that one. Also putting my proxy settings on my client. Also disabling encryption using vProxy. vProxy disables encryption by default. Sorry, not encryption. Compression is disabled by default in this vProxy version. And I will have a kind of online console. The requests will be coming or passing through. But meanwhile, I want to change them. That's why I have a kind of interactive console here. So interactive console may indicate that please use invite with some malicious content to hijack the clients or authorize some calls or something like that. So I can add anything. For example, a customized SIP header. I can use a legit client to call voicemail with a customized SIP header to indicate that I am the original voicemail owner. Please open me. So this request will be forwarded to the server, and the server will forward this to the clients. This is the expected scenario. But we can use this scenario to attack the server itself or the clients. The same attack surface, same attack, can be used for both. In this example, left side has a client, an official client, and my vProxy. vProxy is running with some magic words. Those magic words are attack templates defined in the proxy as well. So we can use these magic words in the messaging. Right side, right top is the client, and bottom is the Skype for Business server. What I do is defining a rule using the online console, interactive console, and putting RTF file as a kind of message content. And I'm sending this after a hi. Hi is the initial message. So when I send custom RTF, it said test 1, 2, 3. This is the log screen of vProxy. I'm also logging. As we can see, this is an RTF content, and it is legit, but it is also forwarded to the client. So I can use an RTF attack here, right? So what I did is sending an RTF file with an image file, but it is very, very big. So it is more than a few meg, but it is not good for Skype for Business. That's why I will use another rule, but this time I will use a customized RTF. I'm a bit delayed. Anyway, this context will be an RTF file with a picture, but the request will be very, very big and will be, unfortunately, refused by the server, because SIP server will say that this is a very, very long request and it is not accepted. But this message will be coming from the SIP stack of Skype for Business. Not by the daemon, not by the filters, and not other stuff. So we have a sort of needle to dig more to the SIP stack. As we can see, we send the file and we get that request entity is too long. But we can use the other options. As I referred to the RTF file, if RTF file is transferred and forwarded to the client, I can send a malicious RTF file, right? I found a vulnerability published in 2 years ago. 2 years ago, there was a vulnerability in Office 2010, an RTF exploit. In the Metasploit as well, file type exploits. I generated an RTF file. I was expecting everything is fixed and patched. That was true. But the challenge is the header of RTF file. Actually, RTF file was bogus, corrupted. So the Skype for Business should process this RTF and forward this to the client. This was the expected behavior. But the challenge is it didn't. It failed somehow. And what we are seeing here is the log, and I will send this request now. This is the RTF file. It's not so big, so I passed the SIP restrictions. So it is in somewhere else. That somewhere else is IAM filter running in the Skype for Business environment. So Skype for Business environment is processing the files, extract the sensitive data or message content to forward to the client. But it is not expected because there was no filtering enabled in the server. As we can see, there's a kind of stack empty message here. This is not a vulnerability. Not exploitable either. But this is also a bug and shows that IAM filter DLL is there to parse the MIME types, different MIME types, and it fails. Because it also processes this, just like the client. That's why every file type box, including Microsoft Word or Excel and etc., every advisory has also Skype for Business patch or Microsoft Link patch. That is the reason, because it is parsed and processed by the server as well. And that server is also used for federation servers, such as Office 365. So we have a practical attack here with some additional script execution. Attacking Skype for Business is tricky, so I need to implement everything. But Wipro had no NTLM support yet because it had some limitations. So I'm still working on it because NTLM authentication also includes some significant signature fields and etc. So I couldn't implement it yet, but it will be coming soon. On the other hand, I can use the official client to manipulate the SIP invite and message content and STP content. So if I use this call request, if it is modified by vProxy, proxy, I can get a code execution, script execution. That attack was 0-day on Black Hat Europe 2015, just a few months ago. And it was valid on Office 365 as well, and including Federation security. So I didn't need any authentication, or I can register myself as a kind of user there, a kind of anonymous user. And after that, I can start that attack. And I could get all the clients executed my unauthorized script. So that was expected. And Microsoft fixed this bug using MS15 and 1.2.3. So how this worked? It has an URL filter as well, but I manipulated URL using script. A basic useless manipulation allowed me to bypass the URL filter. So I use this. Moreover, I needed essential, basic version of the JavaScript, which is the document location here and window location. So I use this. So the thing is, it is valid in the messages, right? What if I use this in the SIP header? It is possible because all invite requests have subject line called MS-IAM format, and that MS-IAM format is a base 64 value, may carry HTML content. So what I did is I put my JavaScript in an HTML. I put HTML to base 64, and I put that base 64 to the SIP headers. So it can be forwarded between proxies, regardless of Skype for Business or not. Until it hits the correct client, it will get unauthorized script execution. So how can I do this, and what is the effect? I can't attack through proxy. I can't attack through the cloud services. What I need to do is adding a custom SIP header. I can do this vPro or vProxy. So basically, if I send my request to SIP PBX server, it will forward this to the Skype for Business, regardless of I have no access to the Skype for Business or the clients. So the clients will receive this message, the meeting request, and the code will be executed. I will demonstrate this just like in a cloud solution. So I will have a kind of attacking client and video, a vPro. What happened? Okay, I will repeat again. The left side, my attacking client, and the other one is my vPro. And the right side has two different clients. What is happening? AV, yes, I recovered again. Okay, I will play this demo and done. What I can do is sending my request through vProxy and hijacking two different clients. Clients are right side and victims waiting for any call. In this case, I am setting my proxy, and I will use only the magic words in the first place, and I will change things after that. First of all, the client should be connected through my vProxy. So I'm showing all these setup from scratch. So you can replicate this action because the tool is available in vpro.com. So what we need to do is setting our service, setting our server interception, and manipulating things in the middle. So it supports attacking URL as well. And this attack URL will be injected to the calls. Those are the magic words you can use. And I'm combining this attack with an old Java attack. So what I need to do is inviting all these clients to a meeting. I can get the client list because I'm connected to the network, just like Office 365 or federations. Or I can get a kind of meeting request. If I will be joining the meeting, my message will be also delivered to the clients. I'm inviting HackMe2 and HackMe3, and I sent the message, and it is waiting. We are waiting because the message will be auto-accepted unless the client refuses it. This is a kind of Skype for Business feature. The call will be accepted automatically if you do not refuse it. When the call will be accepted, the code will be executed, and we have shells. But the challenge is, as you can see, we need to wait for it. Maybe we should not wait for it. We can do something else. This was a kind of meeting injection. But we can use some other attacks. For example, phishing through this content. Phishing needs user interaction. Will not work just like the previous one. So what I am doing is saying hi, and meanwhile I am sending fake Skype update. This is another magic word defined in the vProxy. So it will send updated Microsoft Skype for Business servers detected. Please click that link. You can deploy this message everywhere, so it is possible. Normally, Skype for Business should not allow any links and customize messages like that. And the last one, and PBX bypass like SIP header injection. What we need to do is a console access. So I'm defining this rule on the fly, connecting to my proxy back, and using the magic word vProxy, which enables the console, and adding a rule. Invite subject must be replaced with this content. So it will do its magic for base 64 and obfuscation and etc. When we send this, as you can see, no user interaction, no waiting, it will open the browser and we will get script execution. This attack can be combined with some additional attacks as well. But basically, we need to secure the clients as well as the server, because I have used the server attack and the client attack using the same architecture and same rich messaging. So using the same technique, we can target the server, which is a cloud service in this case, or the client. vProxy is available for all vendors. This is this bug, for example, the code execution bug, script execution bug, sorry, is fixed by Microsoft. But the other bugs, they are still out there, and I'm still working on them. Probably I will work with Microsoft to solve them, because they need some filter slice. So, yeah. This may need some filter work. So I will release them soon. But on the other hand, you can use vProxy for other vendors. It also supports Cisco Jabber, or some Avaya clients, or other TIC clients. So you can put vProxy, and you can change things on the fly. Any VoIP TIC client will work. So you need to secure your design to protect your network, and as well as clients. Of course, enforce your security using SBCs. They will filter everything for you. It is edge servers in this Skype for Business context. Also, enforce authentication. It is much more important than other things, because most of the vulnerabilities are based on unauthenticated users and credentials. And also, inter-vendor configuration is important, because you need to secure your compatibilities. Because vendors may enforce you to reduce the security level, but don't do this. Use the secure way. And also protect the legacy systems. Don't expose them to the B2B UA or CPUA environments, not the subscribers. Of course, protect the clients. Patch the clients and monitor them. If there's an activity, you need to know, and you need to isolate that client or the client structure from your network. So probably you will have questions. We may have some limited time for those questions, but if you have some time, tomorrow, DEF CON 24 workshops, we'll have Voice over IP Wars, the live workshop. So you can come there, you can join me for the live demos and attacks, and you will have USB sticks for the vulnerable VMs and vPro installed VMs to initiate your attacks personally. It will have some takeaways, including VMs and USBs, so please join me. And there's also Black Hat soundbites, which is also important for me. Unified communications. Securing unified communications is not securing just like VoIP. You are not securing VoIP, you are securing all environment, you are securing all communication details. Of course, brace yourselves, because voice over IP attacks are coming. They are in the wild, but you don't see them. Robocalls, toll frauds, or injections, phishing attempts, they are all based on voice over IP. And of course, tailor your communication security. It is required to be tailored for your security requirements. You want to get this tool and the features, vpro.com is a link to provide almost all previous talks and the presentations tools themselves. So if you have questions, maybe I can take, can I? Okay, I can take some questions if you have. Please hands up for the questions, or please take the mic. No questions? Okay, thank you.